Now we shall begin. You should answer the questions as you listen, because you will not hear the recording a second time.
You are going to listen to a radio program on sleep deprivation.
Listen carefully to the first part of the conversation .
With us in the studio today are Dr. Peter Collins, a senior lecturer in the Department of Psychology at the University of Chicago, and Helen Gardner, the author of the book Deep Sleep. They've come to our studio to discuss the effects of sleep deprivation and also give some tips to the sleep deprived on how to deal with the problem. Welcome to the studio, Helen and Peter. Now, Peter, what are the reasons for sleep deprivation and how can it affect our lives?
Well, the research into sleep deprivation started in the late 50s and has been going on ever since. Many researchers link sleep deprivation with electricity, television and computers, which have enabled humans to work 24/7. Before electricity was invented, people's body clocks were synchronized with the sun's schedule, and the average time they spent sleeping was 8 to 9 hours a night. By 1975, that average was down to 7 hours. And today 1/3 of us sleep less than 6 hours a day. This leads to a condition called chronic sleep deprivation, which basically means going for extended periods of time with less sleep than your body needs. Chronic sleep deprivation can cause a variety of physical and psychological problems. At its most basic level, loss of sleep can make us more irritable and less efficient, and can affect long-term memory and concentration, which can result in more accidents. According to the latest research into sleep deprivation is the main reason for 3% of plane crashes, 10% of domestic accidents, 20% of accidents at work, and 45% of all traffic accidents. Research into the physical effects of chronic sleep deprivation suggests more serious and significant long-term complications. Research from my university, the University of Chicago, has shown that sleep deprivation interferes with how the human body regulates insulin and sugar metabolism, which can increase the risk of diabetes. People who are sleep deprived have weakened immune systems and are more prone to viruses and other kinds of infections. People who don't get enough sleep have cognitive problems or difficulties processing and assimilating new information. Lack of sleep affects long-term memory and slows down such abilities as judgment and reaction times. Some researchers link sleep deprivation with obesity, indicating that sleep disorders and eating disorders are often linked.
Thank you. Now we're done with the first part.
You now have half a minute to check your answers.
Moving on to the second section.
First, you have some time to look at questions 1 to 5. Or
You will hear a lecturer talking about the process of fossilization.
First, you have some time to look at questions 1 to 5.
The foremost exhibition in any great natural history museum is almost invariably a skeleton of a large dinosaur, often the famous Tyrannosaurus rex, or T-Rex as it's usually known. Thus, one would think that these skeletons are plentiful, one for each museum, and more to spare in the basement. Well, here's an interesting fact. Almost every one of those T-Rex skeletons are just copies of the original fossils, and we only have 20 sets of these in the whole world. And the most complete is still missing 1/5 of its bones, and the rest are missing a lot more. And given that these dinosaurs once numbered in the thousands and existed on this earth for perhaps 3 million years, you can realize an obvious fact: fossilization is actually an extremely rare occurrence. Fossilization can only occur when, after an animal dies, it is buried in soft mud or silt relatively quickly, before the body completely rots or is torn to pieces by scavengers. Given this fact, the overwhelming majority of fossils are in marine sediment, where former marine life sank to the sea bottom, where sediment was being continually deposited. This means that we have a fairly good idea of the life in Earth's ancient oceans, but a much sketchier view of the land-based life forms. Fossilization on land needs water and mud, meaning that it is most often near ancient river sites and lakes. But it is still so rare that there are, in fact, large stretches of geological time about which we don't quite know what was happening at all. So, given that fossilization is so rare, the natural question is, what can increase its odds? Well, fossilization mostly occurs with organisms which meet 3 basic criteria. 1, they must have hard body parts, for example, shells, plates, bones, and teeth. Unfortunately, the soft parts just rot away far too quickly to be fossilized. And I say unfortunately because it is often the soft fleshy features that most interest us. An elephant's trunk, for example, would not fossilize, and from the skeleton alone, we would never know the trunk was there. The second criterion for more likely fossilization is that the organism in question must have existed in considerable numbers and be spread over a wide geographical range. This simply increases the statistical probability that one of them will one day be fossilized and hopefully found. Finally, and by the same logic, the species needs to have existed on the Earth for a long time, and the longer, the better. So, these are the 3 main criteria, but there are others. Being a large size, for example, helps us to notice and discover them as fossils more easily, and being a marine organism, as mentioned, helps also. Trilobites, a strange sort of ancient crab, are a perfect example. Their body structure was one of hard plates. They existed over virtually the whole world of their time and over a huge span of geological history, over 250 million years in fact, one of the longest ranges of any creature ever. Added to this, some species could grow to relatively large sizes, and they lived in the sea. Perfect. These creatures meet all the criteria, and as a result, museums all over the world are spilling over with trilobite fossils of all shapes and sizes. As far as fossils go, they are common. So, let's think about T-Rex once again. It too basically meets all the criteria that we mentioned. It has hard parts, being the bones, had some dispersion, and had been around for a long time, although it cannot compare to trilobites in this respect. However, it does have one important advantage over trilobites. It is large, very large, which means we can discover it far more easily than many other fossils. And here's another advantage. Dinosaur hunters are a dedicated and fanatical breed, continually at work in all the likely sites of the world. Basically, us human beings are fascinated by these creatures, so much that we are always searching for them, probably more than any other types of fossil, meaning that more T-Rexes will inevitably spring up in the future, and one is certainly glad for this.
You now have half a minute to check your answers.